Okay, it's on the record. So if you don't have any issue with the B4, I'm going to try to finish B5, but we have visited that. In fact, if you get the reaction here correct, which is 9600, am I right? If I remember correctly. Yeah, right here. You can still proceed to finish B5. B5 looks much more simpler than B4 because it's symmetric, right? You better write B4 right away. It's 9600. And then B5, we would have the uniform load that goes throughout the beam. And then we will have that one. Goes just not throughout the beam. So let us go back and check. You see B5 looks like that. You have the uniform load on from the beam, from the floor on the left that goes throughout the beam. And then from the right that goes only between the two supports. So watch out. Okay, on the left, the tributary width now is this is 0.8, only a half, right? And here is, guess what? 0.6. So it's a bit tricky, but you know, if you say this is difficult, I don't think so. It's not calculus. You know, it's not integration. It's just recognizing the area that your beam should carry. Okay, so 0.8 and 0.6, we can now go back. B5. So let's say this is W1. It is 0.8, right? Multiplied by the total load. How much is 900? Am I right? Nobody is helping you. Okay, 900. Plus the self-weight. Or you can just, okay, I have the floor on the left and then I have the self-weight. You can write self-weight separately if you wish, but it's the same load, so we can, you know, wrap them up together as well. And this W2 is 0.6, right? The tributary width multiplied by 900. So that's B5 for us. Okay. This is 1020 kilogram per meter. This is 540. So B5 looks a lot easier than B4. And again, this is symmetric. Am I right? So R1 is essentially 9600 plus 1020 multiplied by half the length. How much is this? B5? It's a got the dimension. Yeah, the total length is 8 meters and then 1.2. Okay. So right here is 1.2. That's 1.2, 2.4, and 5.6 meters in the middle, right? But total is 8, so that's 4, and then plus 540 of 2.8. Half of that, that's the WL/2, right? The reaction comes very easily. Oh, that's a lot. 15 and 192 kilogram force. And now the rest should be easy. Or you want me to demonstrate again? Let's do it quickly, okay? But again, this is symmetric, so no point doing, you know, the entire length. shear force diagram here is minus 9600, and then you have, be careful, the W1 will bring you down here. So V1 is minus 9600 minus 1020 multiplied by 1.2. Okay. That's minus 10824, and then you meet reaction, so it goes up. Right? This is, of course, the magnitude of your reaction, which is 15192. So that is 4368, and this uniform load of now it's one, you can add them together, becomes 1560 multiplied by 2.8. Yeah, that brings it down to 0. Okay. So if you want 4368 minus 1560 multiplied by 2.8, that's 0. Okay, so bending moment diagram, interesting. Let's see whether or not we're going to have the positive moment, because this area looks so big. Now you know M1 is that area, right? Or you can just take moment, it's easier. Minus 9600 multiplied by 1.2 minus 1020 multiplied by 1.2 square over 2. Okay, so that is minus 12254. My guess is that you're not going to have the positive moment, because this area is only half of 4368 multiplied by 2.8. So 4368 multiplied by 2.8 over 2, so it's 1.4. It's only 6115. So here you have the beam where you don't see the positive moment at all. Here is minus 6139 roughly, meaning it's so heavy that this 96,000 is so heavy that your beam does this, right? Negative curvature throughout, no positive moment. It's possible. So we're done with B5. Except, yeah, I forgot to write B5 here. Any questions about B5? Hello? No? No question. Okay. So that's that. Let's move on to the next example. This is the example that asks you to find whether or not the calculation presented here has error or mistake. Okay. See, okay, let's read it together. The results of the beam carrying the load shown obtained by using a computer program is presented to you by your subordinate. It means you're the boss now, you order someone to carry out the calculation of the beam for you, or he or she would carry it out by using a computer program. Are the results correct? If not, what are the errors? Also, what should the correct diagram look like? Diagrams look like? That is, you need to draw the correct shear force and bending moment diagram. So when you see something like this, you will probably guess, okay, something must be wrong, right? Otherwise, I wouldn't ask. But who knows, right? We better check that. Okay, so I think we better check that. Okay, so the easiest thing is just by checking the reaction. Okay, so reaction. Why do I write there? Anyway, that's going to be 50 for sure, right? Because it's a symmetric section again, symmetric beam again. So we know it's a 50 plus 1.5 multiplied by 5, half of that, right? The entire length is 10. And we take half, so it's 5, because this is symmetric. Let me put the line symmetry here. And then plus 1.8 multiplied by 1. Okay, that's a reaction. So it's 50 plus 1.5 multiplied by 5 plus 1.8. That's 59.3. So you know that is already wrong. How wrong? This is my point of giving a problem like this is I want you to investigate what's wrong. And many students, if not all, will say the reaction is wrong. Of course it is wrong, but why is it wrong? I want to know why. I don't want to know what are the errors. See? What are the errors? And you see right here, if I continue to add something from the beginning, that's 50, and then add 1.5 multiplied by 5, that's exactly 57.5. So what is wrong is that your subordinate completely forgot this load, forgot to add this load into the calculation. So to answer this question, what are the errors? So the errors, actually just one, right? The error is that uniform load of 1.8 ton per meter is forgotten or omitted. Which word you want to use? Okay, that is the answer that lets me know that you know that okay, this load is not included. Not included. Because if you answer that, if you say okay, shear force diagram is wrong, that is what I'd like to say a face value. You look at the number and then the numbers are not correct and you say it's wrong. That's a face value. You don't dig deep to find what causes that. Okay. And then in the end you would probably, yeah, you know, just add this up and then we can calculate this. It's just not that difficult. right? So if we missing 1.8, so it's 0.9 each. I can easily go back here to fix it, because if 1.8 is missing, the total must be 59.3. So that the correct value, you can do it right away. This better be 59.3, right? And then you add 0.9 to that, and you're already on your way. 52.4 and then 2.4. That correct? Oops, sorry, it's 1.8 that is missing. So we better add 1.8. Okay. So 53.3. Yeah, that's more like it. And then that's 3.3. Okay. And then you can fix this with ease, no problem. But I wish that we would be able to see down, because this is the common human error that can happen every time when you use a computer program. Upon graduation, you know, many graduates will claim that they can use the computer program. But what is the major issue is that no computer program will tell you when you miss the load. And this is the comment that I've got from the industrial sectors, that they want the graduates to have the solid background on the equilibrium and free body diagram. So that's why I introduced a problem like this in the exam, just to see if you can investigate, see if you can detect if the error occurs, and you can find it. Okay, it was such a major issue like back then 10 years ago, then that you know, think about someone who think, okay, I can turn on the computer, I can use a computer program, but I don't know what's right or what's wrong. They can just continue to use computer program to calculate something and to design something in the end, while never knowing that they have made mistakes. Okay. So we have more? No, it's a frame next time. So right here, let me go to OBE, show you. See, this is this one. Ability to identify proper result of beam and shear force diagram, bending moment diagram. Okay. And here, if you can identify the errors of input, it's a 40%. And then separate shear force and bending moment diagram, that's 60%. Okay. So generally, not many will get this 40%. Just one sentence to know, to let me know that you actually nail the error of the problem. So to say that the bending moment diagram is not correct, or the shear force diagram is not correct, that's not the error. Okay. Any question?
No,ครับ.
No,ครับ. Thank you. So that's it for today. We have plenty of time, so I better go back and finish this as promised. Okay, right here.
อาจารย์ครับ
Yes.
Could you go back to the question question 3.
Question 3. Okay. Before we here.
I wonder that why is it 53.3 because the load. I mean.
Yeah, right. Yeah, I maybe I was too careless. Maybe it's not right. What do you got?
I got 51.8.
51.8. That correct?
I think it's correct.
Let's do it together, okay?
Okay.
So the reaction is 59.3. That's correct?
Yes, and minus by.
Okay, 59.3 minus
by the 1.5 ton per
1.5 multiplied by 4.
By 4?
Of course, that's 4 meters.
Oh, yes.
3.3.
Okay. Yeah, I'm wrong.
Yeah, you know, yeah, so you should be.
Sorry. Yeah,
It's okay,
I
you know,
simplify on the equations.
it's your learning process.
Okay.
Minus 50, you're down to 3.3.
Too morning for me.
You're
Can
not
you
awake yet? You're not awake?
Yeah, I'm waking already. But yeah.
Okay. So here 59.3 comes from 53.3 comes from 59.3 minus 4 multiplied by 1.5. And that's 3.3. So this moment should be 59.3 plus 53.3 divided by 2 multiplied by 4 plus a half of 3.3 multiplied by 1. Right? Wow, you know what? I think the color on iPad is more beautiful than the color on the notebook. It looks more pink. But let us finish this.
It's 226.8. Oh, plus 4. Oh, yes, plus 4.
Are you okay, man?
Yes.
226.8.9, 0.85.
Yes, 2. Yeah.
Okay. Actually, 0.8 because 85 you put it down. Okay, so that's that. So as promised, let us go back and try to finish this. Okay, here. All right. So let's say we don't know where the point of inflection is. So if we have to assume x is less than 3.2, and then it's nothing. We just write the equation. Okay, and what's the load? It's 6960, right? Here is 6960, 6960, and here is that 300? Am I right? No one's helping me at all. Such a sad person. No one's helping me at all. And the reaction here is how much? 20640. Okay, so if we assume that the first case is going to happen, your equation would be, let's say if you assume that maybe, I don't know, you have a freedom to begin your x from the support or begin x from this. Which one is easier? I can't tell. Okay, so moment, let's say x is there. It's going to be equal to the negative moment 6960 multiplied by x plus 1.6, right? That 1.6. That it? Again, nobody's helping me. Yeah, that's 1.6. So tired, man. Plus 20640 multiplied by x minus x minus 1.6 minus 300 x plus 1.6 square over 2. That's your equation. Then set it equal to 0 and let the calculator do the dirty work. Get x for you. You to 0. Or if you wish to maybe set up your x from here. your moment equation then will become minus 6960 multiplied by x plus 2640 x minus 1.6 minus x minus 3.2 minus 300 x squared over 2 equal to 0. Okay, you have your choices. So that's just the first case, and when it's the second case, it's a different free body diagram. And since we have time, sorry about that. Yeah, my wife goes to the hospital alone. Okay, so assume x is greater than 3.2. So what would it be? Now it's going to be moment. That's going to be minus 6960. Again, I'm using this free body diagram. Okay, this one first. You know, before I forget, this different x has to be less than 4.8 this time, right? Because you begin from this point. So, okay. Now here, it's going to be x again plus 1.6 plus 20,640 multiplied by x minus 6960 x minus 1.6, and then you have another one, 6960 x minus 3.2 minus the uniform load x plus 1.6 square over 2 here is equal to 0. That's the second assumption, where maybe your point of inflection is beyond the second point cloud. And the last one, okay, you have your reaction, and then this, and then this, and then this, but okay, you want to use x from here. Say different x. That's difference. X must be greater than 4.8. Okay, so your moment equation is going to be minus 6960 multiplied by x plus reaction, moment from the reaction now becomes x minus 1.6 minus this x minus 3.2, and then we have another one, 4.8, and then we have the uniform load. Okay. All right, so that's that. Seems like a little bit of a headache. Oh, you know what? Even though I could not be on campus tomorrow, I could still give you a little bit of a souvenir called homework, right? And I have imported the LEB2 class, so it should be there, and you guys should submit your homework there. Now, I'm just gonna post it maybe today. Okay, that's fine. Okay, I don't want you to do the homework in the active session. That's the point. I was thinking about maybe submitting it, posting it a little bit late, but no, I can do it today, give you a little bit more time, and then I can tell you tomorrow just try to practice. Okay. The homework is in fact the modification of the exam last year, and please guys, you better do it yourself for your own sake. And we finished the session quite earlier. I don't know why, but yeah, it's perhaps the you know, being online, it's slightly quicker. So if you have any question, regarding anything, no. Okay, let me stop the record first. Maybe you don't want to be recorded by asking questions. Oh, we have a question. Did I forget the uniform load? You mean, no, I didn't forget the uniform load. I just didn't write it down. Here, that's a uniform load. It's good to ask. That's a uniform load. There. But I didn't write them down. Yeah, right. Okay. Okay. Thank you. So let me stop the record. So, in case you want to ask, but you don't want to be recorded.